Hello, third and fourth graders. It's Mrs. Seals. I'm back for our next science lab of the school year. I said third and fourth graders because third and fourth grade are both talking about the same topic this week, which is what we call physical state of matter. So both grade levels have been talking about what we call properties, which remember are different ways we can describe objects. Third graders, we have talked about temperature, and we have talked about whether or not an object can sink or float in water. And then in fourth grade, we have talked about mass and volume. So as I said before, both grade levels this week are talking about what we call physical state of matter. And what that means is we are going to be classifying objects by whether they are a solid, liquid, or gas. All right, so let's go ahead and get started. All right, so this says states of matter. If you're a third grader, here's your target. It says I can describe and classify samples of matter as solids, liquids, and gases, and demonstrate that solids have a definite shape and that liquids and gases take the shape of their container. And fourth graders, your target says I can measure, compare, and contrast physical properties of matter, including physical states such as solid, liquid, and gas. All right, so let's start with making sure, hopefully by now we all know this word matter. This is going on the fourth week we've been talking about matter. So remember, matter is anything around us that takes up space. My keys are matter, my sunglasses are matter, my pumpkin cream cold brew is made up of matter, the air around me is matter. Everything that takes up space is matter. Matter can be classified into three states: solid, liquid, or gas. So let's start with the solid. Make sure we all understand what a solid is. A solid is an object that has its own shape and size. Solids are breakable, which means they can be broken. Some solids are hard, but not all. Solids can also be soft. And solids can be measured. They have mass and volume. So when I said that a solid is an object that has its own shape and size, what that means is that whether I'm holding it in my hand, or I put it on the table, or I put it on the floor, it's going to keep its shape and it's going to keep its size. It's not going to change based on where it is or if I put it into another container. And then when I said some solids are hard, a lot of kids think that if something is a solid, that means it's hard. However, a cotton ball is a solid, and cotton balls are not hard, right? Your pillow is a solid. Your pillow's not hard. So they're not hard, but I think when kids say that, they mean that they have their own shape. All right. Here are some examples of solids: a shoe, coins, a banana, ice, your pillow, a rock, and me. That's me. I am a solid. Your body is a solid. Here are, now we're going to talk about liquids. What is a liquid? So liquids do not have their own shape. So what that means is that liquids take the shape of their container. So right now I have my pumpkin cold brew in this cup. If I were to open it up and pour it out, it would spill out everywhere, all over my table, because it wouldn't be in a container. Or I could pour it into a different container and it would take that shape, all right? And we say that it fills the bottom of the container first. So notice how right now it's all down here at the bottom. I would have to add more to get it to fill up higher because it's filling up the bottom of the container first. Liquids can pour and spill and flow. And just like solids, liquids can also be measured. They also have mass and they also have volume. Remember, mass is how much matter is in an object, and we can measure that using a balance or a triple beam balance. And volume is how much space an object takes up. Remember, fourth graders last week, we learned how to find the volume of an irregularly shaped object using the graduated cylinder. So here are some examples of liquids: juice, ketchup, water, vegetable oil, milk, soda, and hand soap that we've all been using a lot of lately. All of these things are liquids. They don't have their own shape. They take the shape of whatever container they're in, and they can pour and spill and flow out and make a big mess. What about a gas? What is a gas? Gases expand to fill their entire container. And they also take the volume of their container, which means they take up as much space as whatever container they're in. That's different from liquids. Remember, we said that liquids fill up the bottom first, but gases expand to fill the entire container that they're in. And we're going to see that in just a second, or in a couple minutes. So they take the shape of their container. They have mass, but not as much mass as solids or liquids. So that means they're lighter. There's not as much matter that makes up gases. Here's some examples of gases. The bubbles in a soda or any kind of carbonated drink that you drink, like Coke, Sprite, Pepsi, all those drinks with bubbles, that is a gas. The bubbles are a gas called carbon dioxide that gets dissolved into the liquid, and that's why they're bubbly like that. The air inside of a balloon, whether you blow it up with your mouth or it's at a store and they fill it with helium, both of those are gases. Excuse me. The steam that comes up off of like a pot of boiling water, that is a gas. That's the gas form of water, which we can call water vapor or steam. Fire is made up of different gases, and the air inside of a ball is made up of gases. All right, so let's practice. Ready? I'm going to show you a picture, and I want you to think about those characteristics of solids, liquids, and gases that we just talked about, and see if you can figure out if we are looking at a solid, liquid, or gas. All right? Food coloring. You might use this if you color Easter eggs, or if you bake cookies or cupcakes or cakes and you want to have icing and you want your icing to be a different color, you would use food coloring. So you turn that little bottle over and squeeze it and little drops come out of it. So do you think that's a solid, liquid, or gas? If you said liquid, you are correct. Very good. It is a liquid. Takes the shape of its container. It fills up the bottom of the container first. It can pour and spill and flow. Coffee. Talking about the coffee in the cup. That is solid, liquid, or gas. That is also a liquid, right? Again, we know it's a liquid because it takes the shape of its container. Like every morning I take my coffee pot and I pour the coffee into my coffee cup. You guys know I always spill my coffee, so it can definitely be spilled. So it is for sure a liquid. A hammer. Solid, liquid, or gas? A hammer is a solid. Good job. It has its own shape. This hammer is going to be shaped like this no matter where I put it. If I hold it in my hands, if I set it on the table, if I throw it out the window, it's still going to be shaped like a hammer. It has its own shape. It keeps its own shape. It can be broken. I can measure its mass and volume. Ooh, all right, this is a hot air balloon, and I'm talking about what's inside of it. Stuff inside of it that keeps it up in the air. Is that a solid, liquid, or gas? It is a gas. Very good. So this balloon part is filled with air, with a gas, and that's what keeps the hot air balloon up in the air. All right. So again, notice it's expanding and taking up its entire container? Ooh, here's a tricky one. Are you ready to be tricked? Sand. Is sand a solid, liquid, or gas? Now think about this. I know that sand can be poured. I know that sand can spill. I want to know, I know that sand takes the shape of its container, but I'm talking about each individual little bitty tiny grain of sand. Do you think that's a solid, liquid, or gas? It is a solid, you're right. Now, this is what we call a pourable solid. And what that means is that since each individual piece is so super tiny, when we have a lot of the pieces together, we're able to pour it and it takes the shape of its container, okay? But when we're talking about it being a solid, we're talking about each individual tiny little piece of sand, which is essentially a little bitty tiny rock, right? It's just a little piece of a rock. All right, good job. And one more. Ooh, the sun. I bet I might be able to trick some of you with this one. Is the sun a solid, liquid, or gas? If you said gas, you are exactly right. A lot of people think the sun is solid, like the earth and the moon are solid, but the sun is actually a giant ball of gases that are swirling around each other. Many, many different types of gases. All right, so last question before we do our investigation. So we talked about solids, liquids, and gases. I want to know, can matter change from a solid to a liquid, or from a liquid to a solid, or maybe from a liquid to a gas, or maybe from a gas to a liquid? Or is it just stuck forever? Whoops. Yes, it can change. Solids can change into a liquid when heat is added. This is called melting. Not all solids can melt, but many can. Can you think of something that can melt? There's lots of things that can melt. Ice, cheese, candles, butter, crayons, marshmallows, chocolate, all of those are things that can melt. Melting is when a solid gets heated up and it turns into a liquid, okay? Also, if we have a liquid and we add heat to it, we have another change that happens, which is called evaporation. And evaporation is when a liquid is heated up and turns into a gas. We'll talk more about evaporation later on in the school year. And then liquids can change to a solid when heat is taken away. This is called freezing. So think about if you have a water bottle and you put it into the freezer, the heat is taken away or removed, and then after a couple of hours, it turns into a solid. You have ice. That's called freezing. Another change that can happen when gas is cooled off is called condensation, and that's when a gas is cooled and turns into a liquid. And again, we'll talk more about condensation later on and give some more examples of that. All right, so we'll talk more about changing states of matter within the next few weeks. So what we're going to do now, we're going to do a little investigation. So as we do this, I want you to be thinking about those different characteristics of solids, liquids, and gases that I just talked to you about, okay? So what I'm going to do is I have these 3 little containers. This one has orange tape around it, green, and pink. So one of these containers is filled with a solid, one of these containers is filled with a liquid, and one of these containers is filled with a gas. So since you are not in the science lab to do this investigation with me, it's going to be a little bit trickier, because what I'm going to do, if you were here in the science lab with me, you would shake it and you would get to listen to it and you would kind of get to feel it, and you would use all those characteristics that we talked about of solids, liquids, and gases to help you make your guess about which state of matter is in each container. Since you aren't here with me in the science lab, I'm going to be shaking it. I'll do my best to put it close enough so that you can hear and try to make your guess, but you won't be able to feel it, okay? Sorry, we're doing the best we can, right? Okay, so we are going to start with the orange. The orange container. So I'm going to shake it. I'm going to hold it close so you can hear. Can you hear it? What do you hear? What I hear something that does not have its own shape. And I know that it doesn't have its own shape because as I'm turning this, I can feel the shape of whatever is in here moving around. I can hear it kind of splashing. All right, I can hear it kind of spilling and flowing. It definitely doesn't sound like an object that has its own shape, but I don't think it's filling the entire container either because I can feel it moving around. Okay, so since it doesn't have its own shape, I know it's not a solid. I can feel it changing shape as I move the container. And because it's not expanded to fill up its entire container, I know it's not a gas. So I think the orange container is a liquid. What do you think? Do you want to find out? It is a liquid. Can you see that? It is a liquid. There is water in this container. So if you said liquid, you were exactly right. Good job. All right, ready for the next one? Let's do the pink one next. Ready? I don't really hear anything. Do you hear anything? I don't really feel anything either. So I know whatever is in here must not have a lot of mass because it doesn't feel heavy. But I know it is taking up space. It's taking up the space inside this container. So I know it's matter, but it doesn't seem to have a lot of mass. I can't feel anything moving or hear anything moving. So that I feel like that means whatever is in here has expanded to take up the entire shape of the container. That's why I can't feel it or hear it moving around because it doesn't have anywhere to go because it has expanded. All right. So what would that be if it doesn't have a lot of mass and if it has expanded to take up the entire shape of its container? Is that a solid, liquid, or gas? Let's see, are you ready? It is a gas. There was just air inside of here. Good job. All right, we have one more. Are you ready? This is the green one. Ready? There's definitely something in here. It feels kind of hard. I can feel that it has its own shape. It's not changing shapes as I move the container. It also feels like it has more mass than the container that had the other states of matter in it. Has more mass. I know whatever's in here is taking up space because I hear it moving around, so I know it has volume. So what is that? Something that has its own shape. It has mass, it has volume. It sounds like it's hard. It is a solid. Do you see? There's a marble in there. Yep, a solid. A marble is a solid. It has its own shape. It has mass and volume. It can be broken. Good job. All right. Awesome job. Now we're going to do one more thing before we go. And this is a demonstration to show you how gas expands to take the shape of its entire container. Again, remember liquids, they take the shape of their container, but they do not expand to fill up their entire container, because look at my cold brew. It's only to here. It's not filling up the entire container. It didn't expand, okay? But gases, they do. So I'm going to show you that. So right here, I have this water bottle that is filled with vinegar. It looks like water, but it's not water, it's vinegar, which we've used vinegar in the science lab before. It looks like water, but it has a very, very strong, almost kind of like a sour smell, kind of like pickles. It's used for cleaning and cooking and different things. And then in this balloon, I have baking soda. Baking soda. Yeah, baking soda. I got confused and thought maybe baking powder, but it's baking soda. Baking soda is a white powder that's used for cooking and cleaning also. It doesn't taste good, but sometimes people put it in their baked goods to kind of make them a little bit more fluffy. All right, so I'm going to show you what happens is when vinegar and baking soda mix together, they create a gas. So in this balloon right here, I have some baking soda. And in just a minute, I'm going to lift it up and I'm going to dump the baking soda into the vinegar so it falls down. And it's that combination of the vinegar and baking soda is going to create a gas, and it's going to inflate the balloon. And you're going to see the balloon fill up with gas. Are you ready? Hopefully I can do this without making a big old mess. Oh, there we go. Do you see that? Isn't that cool? The vinegar and baking soda combined to create this gas called carbon dioxide, and it filled up the balloon. And the entire balloon is full of gas. I can feel it because gases, they expand and they take the entire shape of their container. Isn't that cool? This is something that if you would like, you could try it at home with your parents' permission. Remember, we never do these science experiments without a parent's permission. All right. I hope, oh, can I let go of this? Oh, goodness. Oh, goodness. Oh, look, the gas is coming out. Can you hear it? It's deflating because there's a little hole in this balloon. Oh no, I'm going to have a big mess. Oh, I better go. So remember, solids, liquids, and gases. When this video is over, you're going to go into Schoology and take your short quiz on solids, liquids, and gases. Remember that it is not required. It is not for a grade. It's just extra practice for you to make sure you understand solids, liquids, and gases. I will see you next time. Bye, guys.